SEPS Strategic Plan. Proofs of Concept. As part of the SEPS Strategic Plan, proofs of concept were developed to demonstrate workflows that will be possible if the strategic plan is implemented. The proofs of concept are not comprehensive and are intended to be demonstrations of some potential workflows and tools. The tools used were not selected as the only solutions possible, but to illustrate what type of an ecosystem could develop in the next version of SEPS once a services-oriented architecture is enabled. Some of the proofs of concept are fully functional or partially functional demonstrations. They are not intended as final working solutions. Other solutions and vendors are encouraged to demonstrate how their solutions fit into the SEPS ecosystem. The goal is to create a plug-and-play modular platform that will allow any number of current or future solutions to work with SEPS. Proof of concept number 6, SEPS to design and specifications. Huge efficiencies can be gained in making SEPS data flow into design and construction in a machine-readable format through web services. The current process is output from SEPS in an Excel format for PFD, Program for Design, and project room content. The designer then interprets these requirements to create design documents. The data is then looked at in many different ways. So for example, the master specifications that are on the VA website with links to Word documents for each specification section are interpreted. So in this case, if SEPS says we need vinyl composition tile in this particular room, the designer has to make sure that the relevant spec section is included in their documentation. This is just one small example of data being managed manually in a Word document. The designer also then creates the CAD or the BIM file to create the construction documents, and the spec writer might also coordinate between the BIM and the CAD files and the specifications, either manually or through commercial off-the-shelf software that exists for specification management. All of these steps are a manual hop from one step to the next, which increases the potential for error and also increases the time to manage the data as changes happen, and also just to coordinate between the different documents manually. One example, if we take SEPS to max.gov and use a services-oriented approach, if the SEPS project data is made accessible, applications could read from it directly, for example, to create an automatic blocking and stacking model, and then use that model in that application. In this case, we're showing the Onuma system to resolve the design. The floor type would be automatically generated. The color coding here is for floor type, but all the other attributes would function pretty much the same way, that the attributes from SEPS then would be directly impacting BIM automatically from even the initial output from SEPS and carried on through the design. In this scenario as well, the automatically generated graphical view of the model with the colored floor plans could also generate an automatic link to what even currently exists on the VA master construction specifications as a section. So for example, the flooring section as a Word document that's currently linked to a URL on the VA site could be automatically linked back to the BIM, even the initial BIM, the blocking and stacking BIM, that was directly driven from the SEPS project data output. In other words, all of this could be an automated process even on the initial import or linking to the project data. In the future, we believe the master specifications also has a potential of being web-enabled and services-oriented with a services-oriented architecture approach. But for now, the current version are links to Word documents. The design that was initially generated from SEPS as a blocking model could then be continued on into design and construction BIM. In this case, we're showing the link from the Onuma system to Revit with the SEPS data flowing through into the Revit model, including the equipment data from templates or automatically generated from the SEPS data with blocks in the space. Another approach to the specifications is from a company called eSpecs that currently has taken the VA Master Construction Specifications Word documents and converted them into the eSpecs database, um, which makes it much more powerful as far as being able to get the granular information in the specs rather than just entire sections in a Word document format. eSpecs currently has a capability of taking a BIM and working with the architectural team. The input from the BIM can also be linked to the specification, in this case the VA specifications. But in this proof of concept, we're showing that the SEPS project data that's automatically generated from SEPS in max.gov as a project data that says that we need vinyl composition tile could trigger the automatic generation of a specs section by linking to eSpecs through web services to create a more granular specification with rather than just an entire Word document format. So in this way, the initial graphical view in BIM and Onuma system BIM, in this case with the floor coloring, could also be aligned with the eSpecs data and the detailed design and construction BIM. eSpecs has been presenting the concept of using web services and the cloud and being able to get to granular spec data. They've identified this as the way things should go in the future. So not having to deal with data as they described it here on this page as a 1,000-page PDF file or Word document. This is going to be critical to get to the granular data connected to the BIM using web services. And in this example, it shows how the eSpecs specifications can take the floor type code from SEPS and then find the relevant section mapped to the eSpecs data. So when VCT is selected in SEPS, the resilient tile flooring section with the VCT option selected and the resilient base and accessory section are inserted into the spec project. The filtered sections are available in the project manual document, and the associated data can be consumed by the model apps and other downstream processes. So you see on the right side it's actually editing specific words out of the data, and in this case the data of the specifications, rather than dealing manually with editing it. So the SEPS output automatically now impacts specification by being able to connect through web services to a tool like eSpecs. Another example is the concept of macro BIM. There's a pilot going on right now with the Beck group and the Onuma system for VA, focused on macro BIM, looking at data and how it can rapidly generate planning models. This also applies directly to the SEPS as a services-oriented architecture concept again here. Same concept. If SEPS project data is available as a service from max.gov, the Onuma system can automatically read that data, generate a blocking model with the appropriate color-coded spaces and equipment in the spaces, etc. And the link to dprofiler is through an XML file that then dprofiler can consume and create a model, a macro BIM model that can do all kinds of more detailed cost estimating driven from the SEPS output of the project, the areas, the space types, the flooring, for example, and do a very rapid constructability and cost estimating. So the scenario planning here using data as a tool coming from SEPS and services-oriented architecture dramatically increases the flow of project requirements into design and construction. So with this ecosystem, you can actually start seeing how specifications, early blocking and stacking models, SEPS data driving that as a requirement model. Let's say the one under web-based BIM checker is showing the kind of the client requirement model. And then as the design progresses from the early initial automatic generation of the blocking model through design, dprofiler, for example, or into Revit, and the eSpecs are getting attached to it, and the design is being resolved, you can start doing a delta comparison between what was the original output requirement from SEPS as a service here, as a project requirement, to what is the design team currently doing, and do an automatic delta calculation. For example, in this case, we're showing square footage calculation deviations in square footage from requirement model to the design model. This type of automatic comparison, there's a lot of other tools available as well, like Celibri Model Checker, that can start looking at specific criteria that say, here's what needs to happen. Making the data granular and accessible just dramatically increases the ability to look at the entire facility life cycle of a project, SEPS going into design and construction and beyond. Making it machine readable dramatically increases the value of the whole system and creates an ecosystem to connect using commercially off-the-shelf available applications that support SEPS data. Now let's take a look at this web-based BIM application that has connected to SEPS, a program for design requirements. And this will illustrate how through web services we can actually match what is coming from SEPS, the room numbers, for example, and IDs and the room names. And the color coding is actually, this is a floor finish color coding, so you can see the purples are the vinyl tile flooring. And if we click on one of these spaces, you can actually see the pull down. So if we go to the attributes, for example, this has all the different categories of spatial attributes, wall finish, etc. But floor finish, for example, if we pull down on any of these attributes, this could be coming directly from web services. This is a list of the naming of floor types in SEPS. This little detail here seems like a minor thing, but actually it's huge in a project. If you start a project and you don't have a complete list of floor finish types, and there's hundreds and thousands of these attribute groups that are in SEPS that are absolutely critical to have a full list of, regardless of if they're specified in the project or not. So for example, if the designer decides for whatever reason that it's better to change its floor type, if they don't have the category name here that is the full list that's available, because the output from SEPS might have missed a couple of floor types, and all of a sudden the PFD only has that floor type, then you're starting to make up different names, which starts just trickling down into all kinds of problems later on in the design and construction. So this is a web services link demonstration to SEPS standards that would show up directly in BIM like this. And then as you resolve the BIM, this one's obviously the early planning model, so the designer would start working things around, and then as they start resolving the design, it would start looking something like this model. And connected back to other desktop BIM applications, you can start doing checking. And so for example, you could say, give me a delta comparison. So red here means that the square footage of this particular room is more than 20% different than what is required in SEPS. If I opened up a report here, it would be generating that report with a square footage differential between the required to the PFD to the current design. With percentage and square footage difference. So as a design changes, it would be comparing back to the SEPS project requirements, which would be through web services. So this could be a live link to the project requirements back to the design that's being created right now.